We have Rick Moscow. He's an associate principal at WJE here in Pasadena. Rick has inspected over 2,500 structures for various organizations. He has extensive experience in architectural and structural forensics, building enclosure commissioning, and building enclosure and roof consulting. Mr. Moscow has investigated numerous property types, including residential buildings, hotels, restaurants, industrial buildings, schools, medical facilities, among other types of buildings. He has also served as an expert witness in numerous litigation cases and is well-versed in due diligence reports and disabled access compliance review. Michelle is involved in design and preparation of documents and specifications for numerous building components, including an exterior envelope, roofing, waterproofing, and window systems for both new construction and repair of existing buildings. She performs field testing for air and water penetration resistance, both in the context of new construction and in the forensic capability. Michelle frequently acts as a consultant to architects, contractors, and owners in peer review of new roofing and waterproofing systems. She has experience with various building types, including medical centers, university facilities, high-rise hotels and residential towers, and multifamily complexes. So I'm pleased to present to you their presentation on stucco detailing for buildings with unique geometry. Bear with us a moment while we switch presenters as well as toggle the audio functionality.
All right, so we're going to start off. I think, Ivan, can you unmute Rick as well?
I think Rick is unmuted.
Okay, can you hear me now?
Yes.
Okay, great. Well, welcome everyone. Again, I'm Rick Moscow from Wishkin Nelson Associates in Pasadena. Very happy to have you here. Glad to be assisted by Michelle Sandoval. And we're going to be talking about stucco buildings with unique geometry. And we'll explain what all that means in a little while. Let's see, there we go. So this course is approved for AIA credit, so if you are going to be listening to it and you need some AIA credit, we'll have a way to get that to you through the IIBEC office. Ivan can help take care of that. It is copyrighted by WJE, the presentation. And what we're going to be doing today is we're going to start with a focus on discussing typical performance characteristics of three-coat stucco-clad wall systems. We're going to talk about some of the common issues that result in water leakage. And Michelle's going to take you through most of that. And then in the end, I'm going to jump back in and I'm going to talk a little bit about how unusual geometric features can affect the way a building performs from a water-resistant perspective. In the end, our goal is to provide you with an understanding of how these unusual geometric features can affect the behavior of water in the stucco system. And we want to be able to assist designers, builders, anyone who's involved in the construction, how to avoid these potential water intrusion problems due to inappropriate detailing. So I'm going to turn this over to Michelle, and if you want to take over the screen here.
Okay. So as Rick said, I just wanted to start off with, a little bit of a precursor, brushing up on some stucco basics, talking about the different types of stucco cladding, such as the barrier system and drainage system. So typically we know, so, oops. I don't know. Rick, are you moving slides?
No, I'm not touching anything.
Oh, okay. There we go. Okay, so barrier system. Typically we got, that would be stucco directly applied to a CMU cast in place concrete wall. As you can see in the graphic indicated with the blue arrow, where we've got, water not penetrating the actual stucco assembly, since there's no actual drainage plane behind the stucco in that particular system. So generally for a directly bonded stucco system, we have either against CMU or concrete. The kind of biggest difference is there's no weather barrier behind the stucco assembly. And it's pretty critical for the stucco to be actually fully bonded to the substrate, since that's what really allows it to perform as a barrier versus a drainage system. And then a more common approach that we see is the drainage system, where we have a drainage plane behind the stucco assembly. And this drainage plane, will consist of a weather-resistive barrier and flashings, which allow water to evacuate that actual drainage plane. This graphic is just, one particular profile that could work for that as far as a drainage medium, but there's different profiles that can work for that. So as Rick mentioned, we generally know how water behaves when we have a drainage plane in stucco, and it's generally predictable, what path it will take. And this changes with buildings with unique geometry. But although water management can be generally predictable, we often see some common mistakes either in design and construction that do lead to water leakage. And these, as Rick will get into later, can be further intense with buildings with unique geometry. So just a little bit of a precursor, a little brush up on typical stucco components. So generally we either have 1, 2, or 3 coat stucco, either ranging between 3/8 to 7/8 inch thickness. Most typical, we have a 3 coat stucco with 7/8 inch thick over a metal lath. In addition to a lath, there are also several other accessories for stucco, such as control joints, reveals, expansion joints, through-wall flashings, and other penetration flashings. We also have any sealing joints that go around perimeter. But in order for the stucco to really perform properly, all these components need to work together to actually have a proper water management system. Unfortunately, all of these parts are not always properly designed or installed. From our past leakage investigations, we often see common issues with either poor installation of the weather barriers, failure to provide or install through-wall flashings properly, poor installation of metal lath, and different accessories, as well as application of the stucco in a horizontal application. So getting into a little bit of information from what the code actually requires. So IBC and CBC both require just a minimum of 1 layer of number 15 asphalt felt for complying as the weather barrier. For wood-based sheathing, 2 layers are required, and each layer needs to be independently installed to allow for drainage plane within each layer. As far as different types of weather barriers, there are definitely quite a wide range. There's loose laid sheets, self-adhered sheets. Loose laid can be felt, paper, building wraps, different types of actual sheet products. Then we have fluid applied membranes and adhered membranes. From our experience, usually 1 layer of building paper is generally not adequate, particularly if there's compounding issues at flashing conditions that can allow that 1 layer to fully saturate, and then in turn saturate any sheathing or in even framing behind that particular weather barrier. We also have often seen some of the loose laid sheets that can bond to stucco if there is no sacrificial layer of building paper that might be used as a slip sheet between the loose laid sheet. So generally, we typically would recommend either a fluid applied or self-adhered sheet product that can be wrapped into openings, followed by essentially a sacrificial layer of building paper that can act as a slip sheet between the backside of the stucco and the fluid or self-adhered membrane. So for flashings, again, IBC and CBC, similar requirements as far as the purpose of the flashing to allow for water to evacuate the drainage system. And essentially it also requires flashings around typical transitions such as different deck conditions and window assemblies. So as far as other standards that are pretty common industry practice for following stucco application, we have ASTM C1063 and ASTM C926, which both help with specifying standard practice for application of the lath and the plaster. Both, so ASTM C1063 has more specific language on what's kind of flashing would be recommended for the base of the wall, as well as different through wall flashing requirements that essentially help with the management of water and to evacuate it from behind the drainage plane to the exterior. I think there's a delay. Okay, so although we have language and standards and different code requirements for how these different flashing conditions should be either installed or incorporated with the stucco system, they're frequently either possibly detailed incorrectly or installed incorrectly, and oftentimes these flashings are just not incorporated in either the correct locations or in the correct sequencing. So typically, through our various investigations, we have seen the most common examples of issues are at areas at balcony transitions, window heads, and different penetrations such as pipes. Here we can see a typical balcony transition where no saddle flashing or other form of base of wall flashing was incorporated, which led to water being trapped in this area and saturating the building paper behind. So a more appropriate detail for this type of condition would be including a saddle flashing that wraps around that edge and a self-adhered membrane that transitions with that flashing, as well as then a weep screed and different casings that would finish the transition at that balcony edge and actually allow water to drain around that edge condition. Oftentimes for window heads, we do have a head flashing or drip flashing incorporated. However, unfortunately, sometimes we see this not lapped properly, not where they're lapped with the building paper. So depending on the way the actual flashing is installed, although it might be there, it's not flashed properly, and the building paper is lapped behind the flashing, allowing for water to just get trapped behind the flashing and not have a proper path to evacuate the water in that condition. This is just another similar condition where due to lack of any roll transition, water can get trapped, and then once that, like we said, if one layer of building paper oftentimes not sufficient, and once that's saturated, it leads to water leakage to the interior. So options for that for a better detailing of those types of transitions include having a self-adhered membrane as part of the termination of that sheet metal window head drip flashing. Also having this similar detailing could be done for through wall flashings at floor lines and different horizontal joint conditions. Here as well, you have the window head flashing extending past the window head as well, which allows for evacuation of the vertical stucco assembly above that as well. So pipe penetrations are also often either not flashed properly, or possibly the gap between the pipe penetration and the cladding surround might rely on just an exterior sealant joint, which oftentimes will deteriorate over time and not perform. So a better approach to that type of detailing would be to include a self-adhered membrane around a target flashing around the actual pipe penetration with a full fillet bead of sealant around the pipe penetration, which then gets integrated with a fluid applied weather barrier for a pretty robust indication of full flashing around that pipe, eliminating any potential gaps that might occur from the pipe perimeter. So oftentimes we see another possible source for water leakage through fasteners for lath attachment. Although lath attachment is generally supposed to go into the framing members, we have found some instances where shiners or fasteners that don't actually penetrate into framing members are observed throughout the height of a whole stud, which can then lead to multiple unsealed penetrations through the weather barrier. This could be avoided by having some form of coordination between the different subcontractors. Generally, whoever's installing the sheathing or the cladding may not be the same sub. Therefore, in order to have a way to document and to actually mark out where the framing is included, therefore any attachment is actually done back onto framing and not in the field of the membrane. So you can see here the lath following the red marked lines of where the framing is actually included, that avoids any kind of loose fasteners that might be offset from the actual framing. So different accessories, most common are metal accessories, but we also see vinyl accessories as well. One of the most common accessories, we've got control joints, which we typically recommend are wire tied, and we have then the screw fasteners for the actual lath. So here you can see wire ties for a vertical control joint to the lath itself. This allows the control joint to actually move freely and not be restrained back to sheathing if it's screwed on. Also, you can see here another important condition for control joints is to have the lath be discontinuous between the two sections of the control joint to allow the two sections to actually move independently. So one other item that we typically see that might lead to issues is application of stucco in a horizontal surface. We typically see these areas are either not sloped correctly, which can lead to standing water in these areas, and any cracks in these top horizontal surfaces can then lead to excessive water being put into that cavity. So typically for any application of stucco on a horizontal surface, you want to include a sufficient slope. In Southern California, we don't have snow or ice accumulation to worry about, but sufficient slope in certain regions might require more slope to be able to allow snow to slope away from that condition. Obviously here, if we have any areas with low slope, standing water could be an issue as well. So typically we would recommend either just avoiding stucco in that kind of application, using a metal cap flashing instead of stucco, or if stucco is the route that will be used, it's best to limit any kind of fasteners that are used on the horizontal surface, and always wrap a self-adhered membrane beneath the weather barrier to add for added protection on that horizontal surface. And I will turn it over back to Rick. See if that works.
Okay, let's see. Get my sharing. There we go. It looks like we got it. Thank you, Michelle. Nice job. Appreciate it. Now we're going to start talking about, I think, what probably interested a lot of you, and that's, first of all, what does it mean to have unique geometry, unusual geometry, and how does that affect the stucco? So what we've got here is we're going to be talking about things like diagonal control joints, diagonal window heads, diagonal window sills, all kinds of things that are not commonly used in buildings. The basis of this discussion is it was brought about by a litigation case I was involved in several years ago. And we were retained by an attorney who was representing a stucco subcontractor who was being sued for construction defects. By the time I got involved, there had already been a report done by the plaintiff's attorneys and their experts, and pretty much the report said that our client made a lot of mistakes, and we had to agree that there were a lot of construction defects that certainly led to the problems. But in reviewing it, I concluded that there were additional problems besides the construction defects, and I concluded that the design itself wasn't really appropriate because of the inclusion of these diagonal accessories and diagonal termination conditions. The system on these buildings is a 3-coat plaster system over metal lath. There was a layer of building paper, one layer of a sheet polyolefin air barrier, and then gypsum sheathing and steel studs. The water intrusion that we saw in the report that the plaintiffs prepared clearly showed the installation errors. They had done water testing. They had found leaks that replicated leaks that had been going on in the building before the litigation. And when they did the destructive testing, they were able to find these defects. But the report also highlighted a lot of areas that had leaks, but did not have observable defects in the installation. And based on reading that, I concluded that I thought there were some problems with the way the building was designed and how that was going to work with these diagonal accessories. So diagonal accessories behave differently than normal accessories. When you have traditional geometry, horizontal and vertical installations, you have a path of least resistance for the water that is more predictable. Generally, it moves downward with the flow of water, and it's generally a uniform flow of water. You don't really have a lot of high concentrations of water. With the unique geometry, these diagonal accessories, the path of least resistance to the water is less predictable. It's irregular, it often flows diagonally along with the accessories, and it also leads to a potential for collecting water in high concentrations in localized areas. The traditional geometry is also more predictable in the performance of non-standard detailing, and we'll talk about what that means in a couple of minutes. With the unusual geometry, the non-standard detailing made things a lot worse. They weren't that great to begin with, but they were made a lot worse. So after we were retained to work on this, and I had this theory that the diagonal accessories and diagonal terminations were contributing to the leaks, we decided to do some testing. Now, unfortunately, I don't have any pictures for you to show you of the actual building. I can't show any pictures of the original report or pictures of the building because the owner of this building is a government agency that had, shortly before this litigation, had been the subject of several rather scathing reports of construction management problems. So they have never allowed us to have any photographs or access to any of the litigation information. But we were able to do some testing of our own. So what we did was we decided to build two mock-ups. And we built them in a laboratory, in a warehouse. There's a picture of one of them. The other is virtually identical. It's facing that one. So the two mock-ups were facing each other. One of the mock-ups was as designed. It was built the way the architect designed it, without any of the construction defects that our client had created. The second one was built according to design, but with the same construction defects that we found and were found by the plaintiffs. And both these mock-ups were constructed. They were allowed to cure and shrink to the greatest degree possible. This was done in the summer. It was inside a building with large doors. It was pretty warm, but neither of these mock-ups were ever exposed to sunlight or strong winds. So we wanted to give them a long time to cure to try and induce some of those cracks. And then we further actually induced some cracks artificially that replicated some of the cracks that were identified in the original construction because we wanted to be able to test how the weather barrier works when water does enter through cracks and joints. The water testing was done in accordance with ASTM E2128, and that testing procedure allows us to use something that many of you are probably familiar with. It's called ASTM E1105, and that's also called the spray rack test. So we had the spray rack assembled. Both mock-ups were provided with negative pressure, and we tested the as-built wall and the as-designed wall. The intent of this was to allow for us to have independent consideration of both construction defects and the design issues. So as expected, the mock-up that had the construction defect leaked pretty quickly. We were able to document a lot of the same kind of leaks that they found in the original investigation. But we also found leaks in the as-designed building, the one that was built the way the design called for, but without any of the construction defects. And those leaks occurred in similar locations as we had seen when we reviewed the report from the original investigation. The mock-ups also allowed us to evaluate some repair procedures. We wanted to consider whether it should be reclad as it was originally designed, or if we decided that the original design was not adequate, that we needed a new design for recladding, and then we wanted to consider the possibility of a barrier coating. So the mock-ups included several features. We have horizontal and vertical control joints, and we have diagonal control joints. So as you can see, this mock-up, all these shapes you see in the mock-up were in the existing building, the original building. What's different about the mock-up is the mock-up is only 24 feet long. The building was very large, and for example, this channel reveal, which is about 12 feet long, there were channel reveals in the original building that went 30 feet. So when we identify some problems that occur with these diagonal materials, those were exacerbated by the long spans. So, as Michelle brought up before, the intent of control joints is to accommodate usually shrinkage, cracking, but any other minor movement. Again, we did allow the the buildings to shrink a fair amount, probably not as much as they would if they were outside, but we got decent shrinkage. And then we take a look at the control joints and how they're installed. Now, control joints are generally should be installed in accordance with the STMC 1063 that Michelle brought up before. And the intent of a control joint, when you install a control joint, the idea is to allow water to continue to flow